Good morning, good afternoon, good evening, everyone, and welcome to another episode of Global AI Notes. Today we'll be talking with Vedant Agarwal. We'll be talking about neural networks for real time personalization. So, see you in a second. Good morning, Vedant. How are you doing today?
I'm doing good, Sammy. How are you?
I'm doing well. I'm happy to be back here on Global AI Notes hosting this incredible show. Now, Vedant, can you please introduce yourself? Who are you? What do you do in your day-to-day work?
Perfect. I'm Vedant Agarwal. I'm working as a senior software engineer at Walmart in the Bay Area. So, what I'm currently doing, I'm a part of the search team, primarily the data platform team. So, what my work is to get data directly from the website or the app to the data science teams. That is basically what our team does. And what we do is we channelize all the information, the live streaming data from those sources in whatever format the data science team needs, and we give it to them. That's primarily the high level overview of what we do. So our my work includes bits and pieces of everything in that entire process.
Well, that makes it fun, isn't it?
It is real time. It is fun, but there's too much of firefighting going on at times. Something goes wrong, you go back, fix it, but it's fun. It's a
Okay.
learning process, and you find ways to, make it better, make it faster. And the best part about the job is you get to, you know, if you want to test something, we directly go to the website to see what's going on. So we can track ourselves, our journeys, and then customize what we want as per our needs and see it real time. So that is a perk for me, at least, where I can, experiment with something that I want.
Okay, cool. So, as you said, you're working for Walmart. The
Yes.
presentation you're giving is based on knowledge that you build it working on projects there?
Uh, Kind of, yes. I have been interested in search during my academics as well. So
Hmm.
I have been following. I was working as a machine learning engineer previous to this. So I have been following up on how LLMs are working, how more systems, advanced systems are built on it, and primarily how we can make our search better. For instance, uh, using architecture that I explain here later on in the presentation. I've
Yeah.
always been interested in all of this, and it somehow connects each other and just makes sense.
Okay.
So
Well, you know what? I'm gonna keep my mouth now, and I'm gonna share the slides, and then looking forward to learn more about it.
perfect. Thank you. So I'll start. Hello everyone. Good morning, good afternoon, good evening, from wherever you are. I'm Vedant Agarwal. As I mentioned earlier, I'll be presenting on mastering real-time personalization. Uh, in this session, what we'll explore is how advancements in neural ranking technologies are revolutionizing real-time personalization, particularly in e-commerce. From embedding-based indexing to attention-driven models, we uncover strategies that enhance accuracy, minimize latency, and drive conversion rates. That is the primary goal of every search system. And yeah, we can go to the next slide, Sammy. The way that I have set up this presentation is also it highlights the problems first, and then we have the solutions. So we'll start with the challenges in real-time personalization. What are the complexities that need to be addressed? And then how do we enhance accuracy to ensure that recommendations align perfectly with user intent, reduce latency, discuss some scalable solutions that enable faster and more responsive systems. And last would be boosting conversions where we turn personalization into tangible business results. And we'll wrap it up with conclusions. Sammy, next slide, please. Uh, please stop me if you have any questions. I will also keep a check to the comments. So, what are the challenges in real-time personalization? Firstly, we'll start with latency. Latency is when we have a customer journey going on the website or the app, if we have a delay in the search results coming up, it disrupts the seamless shopping journey that a customer faces, and it directly impacts the engagement and sales. If we go to a website and we search for something and it probably takes 2 seconds, 3 seconds more than what we expect, our attention span diverts, and that is a big issue that we have. That is where scalable systems come in play. Accuracy. Accurate personalization is crucial for building trust and keeping engaged. Many systems struggle to capture the preferences and behaviors of individual users. So that is one of the second issues. And then missed sales opportunities are because of lower conversion rates. Personalized experiences are key to driving conversions and fostering customer loyalty. All of this in hand go together with scalable systems. As businesses grow, the volume of data they handle increases exponentially. Personalization systems must be able to scale seamlessly. How it grows is we have catalog data and the user data coming in together. We need to find matches to them, rank them, and give them back. So as the number of users increase, our catalogs also increase from the seller side. So all this must go in hand. Addressing all these challenges is essential for any e-commerce platform aiming to enhance its personalization efforts. In the next section, we'll start with accuracy, uh, what are the challenges, and we'll discuss one of the ways that I feel can be done to increase all these or decrease all these challenges. Sammy, next slide, please. Uh, so, how we do it, there's a multi-tower architecture that I want to explain. What it does is it's a two-tower architecture, the first being for retrieval and the second being for ranking. When you break ranking or return of relevant queries into architecture, the first tower can be retrieval. What it does is we have a catalog and we have a user query, right? How can we get an intersection of what the user wants from probably a million products to specifically 10,000 products, right? So we have to have a architecture in place that enhances our retrieval. That is where the first tower comes in play. And the second tower that I'm talking about is where the ranking, it gets more precise with what the user's intent is. So for instance, tower one might retrieve 100 relevant products from a large catalog, and tower two ranks these products based on the user's history and session activity, and ranking them in the first 40. So the first 40 are the products that you see on the website whenever you type in a query, and that is how it takes place. So it is a funneling effect that happens from a large data set of catalog to narrow down to some relevant results, and then it goes to the final results. And the second part is enabling semantic search. This part is generally used in the first tower, where what we do is when we have to search for something in the catalog, either you can do an exact text match, or else there's something called semantic search, where we have word embeddings used, which can be created of the user query and the catalog, and then we find the closest match to it. For instance, if you search for a comfortable office chair, uh, products with ergonomic features or memory foam, or even keywords which are not mentioned in the user query can pop up because of this. That is where semantic search is a little helpful. Sami, next slide, please. So I'll explain more on the semantic search. So what does it do exactly? Uh, it helps us in contextual understanding of what the user wants and what we have in the catalog. So what word embeddings do is they capture the meaning behind queries. For example, if we say a user searches for affordable running shoes, Embeddings allow the system to understand the terms like budget friendly and economical, which are semantically similar, surfacing products that align with the user's intent. So even if economical was not used in the query, it still shows up. So that is the first advantage that we have of this. It again efficient retrieval. Improved relevance is if a user has recently browsed fitness trackers, a query for running gear might prioritize recommendations for shoes that integrate well with trackers. Uh, it can these as mentioned the first hour, these relevant data when given to the ranker is more precise, and that is where this is helpful. But the thirdly, where it has a very big advantage is its scalable and flexibility. It can this semantic search can integrate seamlessly with architectures like multi-tower models, and and it allows the system to handle millions of items while maintaining high accuracy and relevance. So we have vector databases right now where we can implement all of this and have in better retrieval, but that is covered in the next slides. By combining these strengths, semantic search not only improves precision, but also adapts to the user needs in real time. Sammy, can we go to the next slide, please? So here we have reducing latency as the second problem. The first point is vector databases for fast retrieval. Uh, as I mentioned in the previous slide, when a user searches for running shoes, the system can quickly match the query and embedding. So how is a vector database different from a traditional RDBMS relation? A relational database is we store data like a catalog would be item name and then multiple features that we enrich our catalog with, item price, maybe a category. Vector database stores embeddings of different sizes, whatever we define it to. And whenever a user types in a query, we make a word embedding of the vector as well, of the user query as well, and have the quick match uh, defined by probably cosine similarity or any other similarity, and retrieve those results fastest. So that is where vector databases can be integrated quickly in our system by using an ANNs, approximate nearest neighbors. We can have low latency retrieval in the first tower. The second is model optimization technique where we can, so in the ranker, if we have a neural network, we can use quantization, pruning, and knowledge distillation to reduce the model size to m- to make uh, accurate predictions in lesser time. And the third is caching strategies, where we can cache data, the most recent data, to make faster predictions. So, for instance, if a user is looking for something, we can have that in the first level of cache. And that is something that I explain in the next slide as well. But we can cache different layers. Or maybe there's Black Friday or uh, some electronic sale going on, so we can cache all the products. Instead of ranking all the queries every time, we can get it from the cache store so that our uh, latency is low. We'll discuss some of the things in the next slide. Uh, Sammy, next slide, please. So coming to the first point, efficient similarity search, where we have approximate nearest neighbors. This, and for instance, when a user, as I mentioned in the first slide, where the user may searches for an ergonomic chair, it quickly matches products with relevant features like lumbar support or adjustable height. So this is one of the ways where vector databases are really efficient. Other thing is real-time updates. Keep recommendations fresh. As new products are added or user preferences change, we need to enrich our catalog on a daily or a weekly basis. So embeddings can also be dynamically updated, ensuring that the system reflects the latest data. This is when we put this into use. This is a very big advantage. It's not strict, it's more flexible. And integration with the ranking models refine the results further. After retrieved embeddings, neural ranking models tailor the recommendations based on factors like user preferences or purchase history, enhancing both accuracy and personalization. So, in all, if we add this in the retrieval layer, it, it, it can enhance our retrieval to the queries that we have. What generally happens nowadays is, since there are things that have like a cold start problem, what we can do is we can have a hybrid system where we have retrieval both from a vector database and an exact text match go in hand, and then we can have different weights to what kind of a retrieval do you value more. But that is how it's used generally in the real-time systems. Sammy, can we go to the next slide, please? But there are also caching strategies that we can use to reduce our latency. Like the first one, reduce repeated computations by caching frequently accessed embeddings, profiles or query embeddings, query results. Uh, Consider a product recommendation system where popular items are repeatedly queried. By caching these results, the system avoids redundant computations, reducing latency and improving efficiency for frequently accessed data. Dynamic cache updates ensures that the cache data remains accurate and synchronized with real-time changes. By employing intelligent invalidation and refresh policies, we can keep ensuring that our cache is up to date. For instance, if a new promotion comes up or if there's a sponsored product, we can keep updating our caches so that only the most relevant products that we want to show to the customer can be shown. This is primarily helpful during a flash sale, ensuring that the recommendations are always reflecting the latest data. And then layered caching approach, we what we can do is we can have different layers of caching with different TTL, time to live. Instance, it can be tied to a user session or it can be tied to an hour, whatever. It takes a step further by combining multiple cache layers, like in memory databases handle ultra fast data retrieval. Message queues can streamline data flow, and uh, distributed caching solutions manage large time data sharing. This can ensure optimal performance across all tiers in the architecture. As I said, we can have a first layer being a query, what is the most popular query. Then we can, for most second, with a more time to live, we can have a query and a product pair. So if a particular query is coming, what was the last ranker? What results did the last ranker show up? So all these things can be cached for reducing latency. But going on to how can we boost our conversions? Sammy, please, next slide. Are two methods. Uh, Firstly, our embeddings. Again, we come back to that. Behavioral embeddings and how can we enrich our metadata. So behavioral embeddings are created by analyzing user actions such as clicks, purchase history, and session activity. These embeddings represent users' preference in a multi-dimensional space, allowing the system to predict what a user is likely to engage with next. For example, if a user frequently browses sports gear, their embeddings will prioritize recommendations for fitness-related products like gym equipment, protein shakes. This can be more flexible as compared to when using a relational database where we have to have a hard text matching to accommodate schema changes for different users. Also, neural networks can be used to enhance catalog data by generating tags, descriptions, and keywords that make products more discoverable. Uh, for example, a fashion retailer can tag a plain white shirt as summer wear, formal attire, or office essential based on its attributes. Um, this ensures that search results are both accurate and relevant. And what we do is we try to enhance something on the user side, but also on the catalog side. Uh, Sammy, next slide, please. But how can we enhance the user side more is what this slide is about. So embedding generation, neural networks process user actions such as browsing sports gear, purchasing protein shakes to create high dimensional vectors representing the preferences. What these embeddings do, they capture a user's fitness oriented behavior, allowing the system to categorize them effectively as someone interested in health and wellness. What we do with enrichment for catalog, that can be dynamically done for the user as well. For instance, if the user starts browsing to yoga mats, the embedding adjusts immediately to reflect the change in interest. And this recommendation now prioritizes yoga related products like resistance bands or meditation cushions. Also, if in the previous history we had a user who had more budget friendly option or was interested in a budget friendly options, we would combine that with the new interest to show more relevant products. Then intent prediction, uh, we with these embeddings, it is easier to predict intent and to keep a track of how these uh, preferences of the customer are changing. For instance, as I said, budget friendly, it helps us understand that the preferences are changing. And then seamless integration with vector databases. So there are more like Pinecone, Vespa. These ensure that embeddings are retrieved efficiently. Um, when the user searches, we those searches are converted to embeddings. Then we have ANNs that give us the top relevant products, and these systems are pretty robust to ensure that for millions of products in the catalog, we have millions of embeddings. Sammy, next slide, please. So, summing it up all up, what are the foundations we need to enable better software for personalization? Firstly, scalable data pipeline architecture. This should ensure that the clicks, views, purchases, and other user interactions are ingested in real time without delays or bottlenecks. Apache Kafka or Flink are efficiently can be efficiently used in this. Such pipelines are essential for managing peak loads during events like flash sales, seasonal traffic surges, ensuring that the system is scalable and reliable. And vector database integration helps match user preferences with product features to deliver highly relevant recommendations. Dynamic feature engineering, such as session recency, trending items, or user specific preferences, are updated dynamically to reflect changes in real time. And finally, conducting A/B tests and monitoring key metrics such as latency, click-through rates, and conversion rates provide valuable insights, allowing for regular refinement of the system. In all, if we have all of this, this helps build a strong base for improved personalization. Sammy, next slide, please. Uh, why it is time to innovate is because we understand that uh, user expectations are evolving. Users demand real-time, highly relevant experiences, but there are scalability challenges, and that is where we must also understand that users are more uh, number of users and the number of items in catalog have increased significantly, where we need to have more scalable systems. Also, AI and infrastructure convergence is happening where technologies allow systems to process massive data volumes efficiently. Um, and to boost engagement, uh, drive conversions, foster loyalty, uh, all these things will help our business get impacted in a positive way. And that is where it is a time to innovate, where we can have more advanced search systems. Sammy, the last slide, please. But summarizing, key takeaways from the slides can be in today's fast-paced digital world, users demand highly relevant and instant experiences. Anything less risks losing their attention. So personalization is the future. Uh, Innovation drives results. These tools like vector databases uh, deliver measurable improvements in accuracy and increase conversions, proving their critical role in modern systems. Seamless integration is a key where this type of a system can not only meet current demands but also evolve with user needs and technological advancements. And finally, businesses that invest in these technologies are better positioned to retain users and drive long-term success. Sammy, next slide. Thank you. I hope I wasn't very fast.
Thank you very much, Vedant, for this interesting insights that you shared with us. We do not have any questions from the audience, but what I noticed is that I had in my mind, if I think about personalization, I still think about the classic machine learning, but you're combining it with vectors, databases, and so on. So that gives me also for me a different mindset that it doesn't need to be only classic machine learning, but that you can easily mix it up with the latest technology, of course, as well.
No, that is true. I mean, when you see from a different perspective, and when I had not deep dived into this, we we assume it from a user perspective, but when we see it from what all we have to provide, for instance, catalog is for every company, right? Even for if you take Meta, friends are a catalog, right? All the top friend that you have, Twitter, right? X, uh, which which post to you is the most relevant. So catalog is everywhere. How do you streamline that process of millions of posts, photos, or products to come to filter it down to the top 1,000, and then you get a more relevant search? That is, I mean, it's crazy. The sheer volume of data that goes through it and what all technological advancements are happening in it, it's really crazy.
True, true. Well, Vedant, thank you very much for sharing those insights with us. We're looking forward to hear more from you in the future. And with that, please keep on following us on YouTube. Next week, same time, we will have another session which will be called The Poor Man's Bing Chat, Building a Search Assistant from Scratch. So that might be also a very interesting session. So please join us next week, same time. So everyone, goodbye and see you next time. Bye
Thank
bye.
you, Sammy. Thank you, everyone.